In this video, I will explain a complete workflow for detecting severe heat waves using ERA climate reanalysis data from the European Center for Medium Range Weather Forecast, accessed through Google Earth Engine and analyzed in Google Colab. This method provides a transparent, scalable way to analyze extreme temperature trends over the four past decades from 1979 to 2023. We will walk through how to extract daily maximum temperature at a specific location, convert the data into Celsius and export it to a CSV file using the Earth Engine Python API. Once the data is loaded into Colab, we implement logic to identify severe heat waves defined as days where the maximum temperature exceeds 45 degrees centigrade and categorize them based on duration, detecting heat waves units lasting 5 days, 7 days, 10 days or more consecutive days. The final part of the video focuses on visualization using Matplotlib and Seaborn library. We overlay shaded region on the temperature time series to highlight each heat wave period. The results is a clean, powerful visual summary of how extreme heat waves have occurred over time, insight that can be critical for public health, urban planning and climate adaptation. Whether you are a climate researcher, data analyst, student or simply curious about climate extreme, this tutorial will give you practical tools and techniques you can apply anywhere in the world using open access data and free tools ERA5, Google Colab and Google Earth Engine. So let's explore the code. This code is basically written in two parts. The first part will help us to download the data. Like here you can see I have imported these libraries, then I have defined the point of analysis or the study area. These are the coordinates. You can adjust it for your study area. So here the downloaded temperature maximum is converted into Kelvin. So here you can see this is the piece of code, step 4, which is applied for this purpose. Now apply the same function is applied to the whole record, and here you can see this piece of code is used to export the data to the Google Colab. So now once you run this code, you will get a file in your Google Colab, and then from the Google Colab you can download it into your system. Like here I have downloaded the file in my system. This is a file and you can see it over here. It has your date and maximum temperature. This is the file, and this file you can download this file from your Google Colab. So now again come to the second part of the code, which is this one. So now again import these libraries, and this is the path of the file of the Excel file which I have downloaded from the Google Colab. So here I have uploaded. Here you have just a click and then you have to access the file. Like me, I am doing this download. Click on this file which I have downloaded from the from my Google Drive. So just clicking it and then it will download. As I have already uploaded the file, so it is here, so I don't need to download it. So now copy this path and paste it over here. So, and this is basically the column name as you have seen in the Excel file, maximum 2 meter air temperature, and this is the threshold. So basically there are different types of heat waves, whether you are interested in moderate or severe heat waves. If you are interested in severe heat, write it over here 45 degrees centigrade. If you are interested in moderate, so write it 40. So 40 degrees centigrade is for moderate, while 45 is for severe heat wave. So you can search this threshold value in the literature. You can you can study various research articles and take this value from this particular for your analysis, and then you can cite it that one. So now this piece of code is basically, as we have 5 days, 7 days and 10 days. So if these temperatures remain for consecutive 5 days, 7 days or 10 days, so through this piece of code we will do this thing. So now here again you can see the same thing is continued. If detect heat waves if the temperature remain above 45 degrees centigrade or 40 degrees centigrade for 5 days, 7 days or 10 days, it will mark as a severe heat waves. So this duration, you can take this duration from various research article, check different research article, take this value and use it over here. You can change this value over here, like this one and this one. So you can modify the code. So here again you can print the detection. So for 5 days, this is for 7 days, and this is for 10 days. Now if you want to plot this heat waves, so this piece of code is for plotting the heat waves. So basically it will draw a vertical line over the time series of temperature, where temperature is above 45 degrees centigrade for consecutive 5 days, 7 days or 10 days. So basically you will get 3 different graphics. So these are the graphs you can see over here. This is the graph. Here you can see the first graph. This is the time series. So here you can see this is for the 5 days. For 5 days, ERA severe heat waves for 5 days. So this is the whole time series from 1979 to 2023. So if there is any vertical line, this is basically a target line you can see over here. So if the temperature is above for 5 days at this one, so basically it will draw a vertical line over it. Now come to the second one. This is the for the 7 days. You can see over here, if the temperature is above the target line, which is this one, 45 degrees centigrade for 5 days, 7 days or 10 days, it will mark, you will see over here a vertical line. So this is again the ERA severe heat waves if for the 10 days. So this is basically, this is 45 is the target line. If this is above the 45 degrees centigrade for 5 days, for 10 days, so basically it will mark a line over here. So definitely there is the temperature is not above the 45 degrees centigrade for 10 days, so definitely there is no heat waves. So thank you very much. This is all about this tutorial.